Welcome or welcome back at C Square. In this lesson we will talk about spheres, and you see here a sphere, and also you see in the second picture the radius of the sphere, how it's called, and on the third one you see the diameter. You notice the diameter goes through the center and the radius starts on the center. Obviously the diameter is twice the radius, so very similar property of the two-dimensional shape called circle. This is a cross section. I'm going to talk a little bit more in another lesson. A plane cutting a sphere, and you see you get another circle, a small circle here. But whenever that plane goes through the middle of the sphere, through the center, you get what is called a great circle. Also now we'll have here two more things about the sphere. The volume is 4 over 3 pi r cubed. R stands for the radius, and the surface area is 4 pi r square. These two formula are very useful if you remember, and they are not given to you. So let's see this first example where we have to find the volume and the surface area of this sphere in terms of pi. So if you remember, the volume is 4 over 3 pi r cube. So that means in this case 4 over 3 pi r is 6 cube. So that one will be 4 over 3 times pi times 216. And here you can simplify. 3 goes in 216 72 times, and 4 times 72 is 288. Don't forget the pi. The volume of this sphere is 288 pi cubic units. Remember, the volume is measured in cubic units. Now let's take a look to the surface area. Surface area, if you remember, is 4 pi r square. A way to remember, 4 times the area of the great circle. 4 pi, and again the radius is 6 square. We don't really need the parentheses. I just want you to see how we replace the radius. And 6 squared is 36, and we have 4 times 36. That will be 144 pi. Surface area is 144 pi square units. In my second example, very similar, however, now is the diameter given, and you notice the diameter is 12. So the first thing you want to find the radius. The radius will be half of the diameter, if you remembered, or the diameter is twice the radius. So in this case we have 12 divided by 2, and the radius will be 6. So now if you take a look, this one is the same problem like the previous one. So the volume is gonna be, I'm gonna go back and take it from here, 288 pi cubic units, remember, and the surface area is 144 pi. Okay, now you follow the same steps. On this example, the volume is given and we need to find the surface area in terms of pi. First of all, let me show you how you can draw a sphere in case you need it. You want to draw a circle first, and then draw an oval or an ellipse. This is a sphere. So we know the volume of this guy is 288 pi. The question is, can we find the surface area? If you remember, the volume is 4 over 3 times pi times r cubed. In this formula, I'm going to replace the volume of 288 pi And I want to solve first for r cube. Okay, my final goal is to solve and find r. The first thing you can do is to simplify this pi. They're on both sides and the operation is the same, multiplication. Other than that you cannot, be careful, but in this case we can. So we have left 288 equals 4 over 3 r cube. And now you want to find r cube, solve for r cube, so you're going to multiply by 3/4 to get rid of 4/3. Of course you're going to do the same thing here. So r cube is 3 over 4 times 288. If you do not have a calculator or you cannot use a calculator, I'll suggest you to simplify. Let's see if we can do that. Okay, 4 goes in 288 72 times, and then we have 3 times 72, that will be 216. R cube is 216. So my next thing is to find what number time itself 3 times is 216. That's what it says here. Or if you have seen this, that means cubic root of 216. If you have a calculator and you can use it, then you can do this operation. The number that times itself is 216, or cubic root of 216 is 6. The radius of this sphere is 200. It's 6. So now we can find the surface area, and this is 4 pi r square, and that will be 4 pi times 6 square, and this is going to be 4 pi times 36, and that will be 144 pi. And if you notice, this problem is nothing else than the first problem or the second problem in this lesson, just backwards. We know the volume, we need to find the surface area. And by the way, here you may need this cubic root if the number is not a perfect cube. But in this case, it's a perfect cube. The very next example is the similar of the previous one, but the only difference now for this sphere, again I'm going to try to draw a sphere. For this sphere, oops, that one should be a dash part. We know the surface area. The surface area means everything outside of this ball, of this sphere. It's 36 pi square centimeter. If you remember the surface area formula, it's 4 pi r square. So what do we need to do here? We replace the surface area with 36 pi. And very similar to what we did a minute or two ago, we're going to cancel out the pi first, and we have 36 equals 4 r square. I'm going to divide by 4 to solve for r square. So r square equals 9. And now, very similar, we're looking for a number that time itself is 9, or take what is called the square root. That number will be 3. The radius of this sphere, for which the surface area is 36 pi, is 3. So now we can find the volume. If you remember, the volume is 4 over 3 pi r cube. So we have 4 over 3 pi, 3 cube is here. So that will be 4 over 3 pi times 27. And 3 goes in 27 9 times, and we have 4 times 9, that's 36 pi. If you take a look to this sensor, you're gonna see something interesting or funny. It's just happened. The surface area looks the same as the volume. I'm sorry, the volume, in fact, we found out here. The volume looks the same like the surface area. This is just a special case. Yeah, and by the way, they are not the same because one is cubic units, cubic centimeter here, and the other one is square centimeter. So in fact, they are not the same, just the value itself looks the same. Usually that's not gonna happen. Now let's see some real life application of a sphere, and you see here we have this sphere and has a diameter of 16 and it's fully inflated, and we need however the is leaking and half of the air is out. We need to find the initial volume of the balloon. So again, let's try to draw a picture somewhere here. This is the balloon. Originally, the diameter, this guy, is 18. So if you remember, the first thing you want to do is to find the radius. The radius is half of the diameter. So that will be 9. So we have the radius, we can find the volume. If you remember, the volume is 4/3 pi r cube. So we have here 4/3 times pi times 9 cube. So let me grab a calculator now and do 9 cube, 729. Of course, if you don't have a calculator, you may want to think about simplification. It is possible to do it. Then we're gonna simplify by 3 here, and that is gonna be 243. That's one way to see it. And we have 4 times 243. I end up with a volume of 972 pi cubic inches. Let's use this unit since we have inches. And that is the initial volume of the balloon. And now half of this is gone. So if half of this 972 pi, keep the pi, is gone, how much we have left? It is going to be 486 pi. This guy is half left. Okay, so now we're gonna use the same formula we have here, but we're gonna use this volume. We have 486 pi equals 4/3 pi r cube, and we're gonna need to find this radius cube. It's something that we did before in a previous problem. Pi cancel out, and we have here 486 equals 4/3 r cube. My next thing will be to multiply by 3/4. If you think that's the step, then very good job to cancel out these guys. So we have here r cube, and we have to see, maybe it's a nice number. Okay, I end up with 3. No, it's not. So we have this 364.5 5. So now we need to find the number that raised to the third power is this. That's not going to be possible. We have to take this cubic root. And let me see if I can do that in my calculator, which is a simple calculator. Uh, 364.5 cubic root. I think I end up with this answer. Hopefully it's correct. 19 point. I'm gonna copy the first, let's say 4 decimals. And for finding the diameter, we're just gonna have to double this radius. So whatever number you have in your calculator, multiply by 2. And I end up with, oops. Okay, let me redo the thing. 19.0918 times 2, 38.1836. And now I have this for decimal, but I think most of the time you're going to be asked to round it to 1 or 2 decimals in this type of problem. And let's put the units here, inches. Okay. So you notice the diameter, by the way, is not we have an issue here, right? Because this diameter cannot be more than the original. So there is a mistake somewhere here. Let's double check now. We have 486 multiply by 3 and divide by 4. Yeah, that is correct, and we need to take cubic root oh yeah, that is the problem. I miss it right here. It's not far away, which is good. So in fact the radius is 7.1433, and I'm going to multiply this by 2 and I get this diameter. So I apologize for that. But you see, sometimes we do mistakes. You need to just look to your answer and try to see if your answer is reasonable. Sometimes you can see that, like in that case, I end up with a larger number than I start from, and the balloon is half inflated. Okay. And that's it. I think this one makes sense. The diameter is less than the original one, not like in the beginning. And that's it for this example. In this one we have a spherical tower. Yeah, sometimes you can see this tower like this around the country, and it needs to be painted. And diameter of this guy is 20 feet, and we need to find out how much paint we need. So first of all, we need to find what? The surface area, because that's what you paint here. And the surface area is 4 pi r squared. You go outside of the sphere, so that is the surface area. And we know the diameter, that is 20. So For finding the radius, we're gonna cut this diameter in half. So the radius will be 10. We can go back here and get the surface area now. 4 pi times 10 square. So that will be 4 pi times 100. And that will be 400 pi. That is how much the surface area is. Of course, if you're on a unit, cubic foot, no, square foot in fact, because it's an area. That's what we need to paint. So now how do we find how much paint we need? I honestly like to write proportion. That is a way to see it. So 1 gallon cover 400 square feet. And you know, this is another thing that should tells you that you have to use the surface area. You see that, oh, it is square units, square feet. Now I need to find the surface area. But now I want to find out how many gallons I need for covering 400 pi square feet. Okay, so it looks very similar in fact, right? If you take a look, oh, I can say kind of a 1 gallon because the denominator looks very similar. It's not really. Okay, so here cross multiplication, we have 1 times 400 and 400 pi if you go this way, and here the other way we have 400 times x. You want to solve for x, so you're going to divide by this 400. So we have x left to 1 times pi, which I'm going to use 3.14 times 1 is 300.14 gallons. Now obviously you cannot go to the store and buy just part of a gallon, so probably I will say on this problem I'll round it up to 4 gallons. So in order to paint this spherical tower, water tower, you made 4 gallons. And the last problem in this lesson is another application. Here we see a ball inside of a box, a sphere inside of a cube, and the sphere below fits exactly inside the cube of 10 inches side. So this side is 10, this side is 10, and this side is 10. But I want you to take a look to, and on part A we need to find the volume. What this guy here, which is the diameter of the sphere, is going to be how much? That one is going to be exactly 10, because it fits exactly in the box. So looking to the picture, we know the diameter of the sphere is 10. So what's the next thing to find? The radius. The radius will be half of the diameter, if you remember. So 10 divided by 2, and the radius will be 5. And now we can find the volume of the sphere. I'm going to put an S here for sphere to be sure we know what it is. 4 over 3 pi r cube. So it's going to be 4 over 3 pi 5 cube, which is 4 over 3 pi times 125. So the volume will be 4 times 125, 500 pi over 3. I'm going to keep it like that. I don't think any problem. Cubic inches. Of course, if you need to evaluate, grab a calculator. And this is part A. let's see part B. Where we need to find the volume of the space between the sphere and cube, approximately to the nearest tenth. So here we're gonna need to calculate. So we're gonna need to find the volume of the cube. I'm gonna call it V sub C, and that is what? The side of the cube raised to the third power. And in this case we have 10 cubed, and that will be 1000, right? So, or if you do not remember this formula, length times width times height, because the cube is a rectangular prism, and obviously you get the same value. And now we can find the volume, the space between the sphere and the cube, and that will be the volume of the cube minus the volume of the sphere. So it will be this 1000 minus 500 pi over 3. So let me put that in the calculator and let's see what we get. I end up with this part, 1000 minus 523.58333. So I use 3.14 for pi, and now we have to do the last part, and we have the answer. Space between, volume of space between, let me call it like that, is 476.41. Oh, nearest 10, so we're gonna stay with 4. So cubic inches. Okay, this is the space between. A very interesting part will be to make a ratio of these two volume of the sphere and the volume of the cube. You can try that. Maybe I'll put it on another example. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.